I think a lot of these questions you mentioned earlier that we're talking here whether it's going to be 2 degrees or 3 degrees, and you said it may look more like 6 or 7 degrees. That type of thinking, I think, puts off a lot of people who are maybe not experts on this stuff, and they're just tuning in now because they're hearing the news about this conference, and they think this climate change stuff, it's so immensely complicated. I mean, even getting down to this one issue like coral reefs is so immensely complicated. And they're multiply that times 10,000 with all the other issues out there. How is it possible that we can get together enough scientists, enough politicians with all their different interests and actually get down to what really matters and make the changes necessary when we can't even agree on whether it's 2 degrees or 3 degrees or 6 degrees?
Well, that's true, but I think the real test of our sincerity is whether we protect the most vulnerable ecosystems and people. The most vulnerable ecosystem to temperature rise is coral reefs. They're at the point where they cannot take further warming. We've lost half of them, half the corals already. The people who live on the low-lying island states that we looked at, could be flooded out in a few days out of their homes. So I think we have to protect them. And that my point is that in the long run, and that's the long run, not the immediate run. I mean,
when you say long run?
Well, I mean, these changes... Once you drive your car and put CO2 into the atmosphere, that remains absorbing heat for about 150 years. But the thing is, when that heat's absorbed and then circulates in the ocean, it takes 1,000 years to warm the ocean up. So we're talking thousands of years. The melting of the ice caps introduced long-term changes too. But all of this is very real, even though it's far in the future, and we need to be prepared for that. My point is that in the long run, the situation is much worse than they recognize. Therefore, the need for action is much more urgent. And the third point is we know what to do. The solutions are there and we're not using them. And that's where much more seriousness is required from this process.
But I think a lot of people where I come from would say, why do we need to worry about this if you're talking about 1,000 years in the future?
Well, because these are incremental changes and they don't go up in a linear way. And we're already feeling the effects. I mean, people in the Marshall Islands, as I say, at this time last year, hundreds of people flooded out of their homes and they had to declare a state of emergency. That's getting worse every year because sea level's rising 3 millimeters, 3.4 millimeters a year now. And that's going to accelerate.
So this isn't just long-term. There's immediate short-term risk, things happening right now, but then there are greater risks in the long term.
Beginning to see the effects. That's what's so frightening. So really, I mean, I think our responsibility to future generations means that we don't waste further time talking, that we start action immediately.
My colleague Daniel Nelson and I have switched chairs. That's because during the break there, that's because we're busy digging up news while we bring you this insight and analysis at the same time. Danny, what have you got?
I'm very sorry. I was very rude, but I just had to answer my phone because it kept ringing and I thought someone was lost. Actually, you're provoking a really interesting response here. You ought to go on the radio and TV more. I know we haven't got that much time, so let me just scroll down a couple. First of all, someone says, amazing interview. Are you able to seed all types of coral? Then there's something here that isn't a question. Large ocean flows that keep Europe warm. I think that, I'm sorry, we'll have to come back to that another time. What does he think about the possibility of the Atlantic conveyor being changed? We're getting into some very serious stuff here. But people are very, very interested. Here's one. Does he feel that politicians are open to his findings? Oh.
Yeah, we started to get on that one, okay. But I'm not sure we actually
Let's just go back to the very last one. Are you able to seed all types of coral? Because if they're going, we need to seed them.
At the moment, we're actually growing about half of all the species of the coral in the world, mostly in Indonesia. We're working with villages that have, one village, for instance, in Bali, we have about half a kilometer of reef that we're growing in their village marine protected area. Now, our goal is to grow all the species because we view the reefs that we grow essentially as arcs. We're trying to keep the species alive because the next hot episode could really wipe them out. So we're very concerned about that. Now, there are many other applications too, though, because by growing the reefs, we grow beaches back and we create fisheries habitat. We all know fisheries are in crisis worldwide and everyone blames overfishing, but in fact, in many places, the habitat for the fish itself has disappeared. So if we don't grow the habitat back, people aren't going to have fish to eat in the future. It's no longer a matter of conservation alone. Large-scale ecosystem restoration is going to be essential to future food supplies.
I want to dig just a little bit more into what you showed us in that presentation earlier, where you're able to regrow these reefs, because that I think is fascinating to a lot of people out there and sparked a lot of this discussion on the oneworld.net website. You said you need to put electricity through this metal grid that helps.
Low voltage DC. We're not, it's not electroshock therapy. It's kind of a trickle charge, an electro-tickle, you might call it.
Right, you mentioned a trickle charge, and that's fascinating to me because it sounds like you don't need a lot of energy. And you said earlier in your comments that this energy was being created by a single solar panel. Is that right?
Well, that's right, but the solar panels produce only a fairly small amount, so you can only build a fairly small structure with it. Unfortunately, it's the most inefficient and expensive of all the sustainable energies at this time. It's simply not cheap enough. So I think that wind, wave, and tidal energy are really going to be the key to doing this on the scale that's needed, not solar.
Okay. And yes, Danny?
Sorry, it's interactive, so we like to give the questioners a chance and not hog it. The person who sent the message about the conveyor, which I was trying to translate and making a dog's dinner of, has now said, well, you know what the conveyor is, the Atlantic conveyor. He says, is this... Oh, it keeps changing. Basically, the question is, how serious is it? Could this happen? Is it something we should be worried about?
I think many physical oceanographers feel that's actually exaggerated, and the real reason is that the conveyor belt is driven by the rotation of the Earth. And as long as the Earth's spinning, you're going to get those western boundary currents like the Gulf Stream. But in fact, what we're seeing is that the Gulf Stream and the Kuroshio, which is the equivalent of the Pacific, are warming up much faster than the global average. So they're pumping much more heat into the northern hemisphere. They seem to be speeding up rather than slowing down. But on the other hand, I've put together a global sea surface temperature database from satellite data since '82 when the satellites went up, and a developed database for every coral reef region in the world. Now, we find some surprising changes in temperature. And, I mean, in some cases, they're not what you'd expect. Along with global warming, we're getting changes in global winds. And in some places, the winds are picking up so much that they're actually drawing cold water to the surface, and those areas are warming more slowly than other places. The warm currents and the cold currents are all warming more rapidly than average. What's alarming is the upwelling regions, which is where we get about 90% of our fish from. Those are warming much faster than average. That is to say, the surface water is now so warm and so thick that the cold water doesn't reach the surface, and that means that the food chain's collapsing from the bottom up. Now, we blame the overfishing for removing the fish, but in fact it's being destroyed from both ends simultaneously. And so that's an unexpected impact of global warming on future fisheries.
So we've just got about 1 minute left here. It's all really fascinating. Sounds like there's a lot of bad news here, and there's some good news as well. So bottom line it for us. Is this just about fish, plant life, the oceans, or is this about humanity and vulnerable populations?
In the long run, it's really about maintaining our planet's ability to regulate temperature, CO2, water, and soil resources. And we need to essentially restore the ecosystems we've damaged on a large scale, because if we don't, we can't stabilize CO2 at safe levels. I mean, our survival really depends on that in the long run.
Very interesting. Final question as we're leaving from one of our viewers. He wants to know, is the Global Reef database publicly available?
We've published papers on it. We've published a number of papers on it that you can find on our website, which is www.globalcoral.org. The full database is actually on our website, but I'm not sure it's accessible yet. What we actually intend to do is publish a global sea surface temperature atlas. So anyway, if people email me, I'll provide them the data for any particular place they want, and we need to get the whole thing out completely. But we have published the major conclusions of that in a number of papers over the last years, and but the full database isn't available, but it is available to any serious scientist or someone who needs to see the numbers.
Great, thank you very much. We have one final comment from one of our viewers. He says, astonishing, frightening interview. So we're happy we could bring it to you. Dr. Thomas Goreau of the Global Coral Reef Alliance, thank you very much for being with us.
Well, thank you very much for letting me speak to you and to your audience, because people, I think, need to know that it's a serious issue, but that we can solve it if we're quick enough. But we need to be fast. The longer we take, the more difficult it will be and the more expensive it will be. But we need to turn the Earth into a sustainable path. We all know that.
All right. Thank you very much, Thomas Goreau.
Thank you very much.